I don't know, it's on his Instagram or something
Sounds
like
like no life, no job.
that. Hey, now. Okay, so we are going to be multiplying and dividing radicals today. So everything that we did yesterday applies as a step here. So we need to remember this. So the inside is the radicand, and this thing here is our index. And the rules that we're going to do today, these rules apply only if the index is the same. That's the only way any of these rules are going to work. So remember, with exponents, the base has to be the same. For radicals, the index has to be the same. And then these rules apply. So if I have the nth root of A times the nth root of B, we have a product rule. I get the nth root of A times B, whatever that happens to be, whatever A and B are. Notice, again, same index. Same index right there. Okay, so let's do an example. Suppose I had the third root of 6 times the third root of 12. Well, what am I going to do? Well, the index is the same. So I just multiply those. And what is 6 times 12? 72. But now we need to do what we did yesterday, which is we take that 72 and we simplify it by prime factorization. And when I do, I get 2 cubed times 3 squared. Now I'm doing the cube root, so what's going to end up on the outside? A what?
2.
A 2, and then cube root of, well, 3 squared is 9. Okay, so this is our final answer right here. And then we're happy. Any questions on the product rule? Anyone need to see another example? Yes, I do. I need to see another example. Let's do another example. Mr. Kane, you already know how to do all these.
Exactly.
Shh. Don't give me the lip. Here we go. Next one. There are several ways to approach the problem that I'm doing right now. So if what I'm about to do confuses you, then do it the same exact way you just did the last question. And I'm going to explain here before I approach this problem why I'm not going to do it exactly the way I did the last question. I do not want to, in the end, these indexes are the same. So what am I going to end up doing? I'm going to end up multiplying. But what does that mean I'm going to multiply? 81 and 32. Well, what's 81 times 32? Something big, right? Is the bottom line. Something big. I do not want to prime factorize that. So what I'm going to do before I even start that, I'm going to prime factorize first. You don't have to do it this way, but in this case, it's going to make this a lot easier to prime factorize first. So I'm going to prime factorize that 81. And when I do, I get 3 to the 4th. I actually don't know about the 32, so I'll go ahead and do that. Now 8 is always 3 2's, that's why I'm just squaring that. So I get 2 to the 5th. Any questions on what I did there? Now after I prime factorize, I'm basically going to treat the numbers like variables. I'm going to treat them exactly the same way. So remember the product rule of exponents, that when I multiply, I add their indexes. Boy, my computer is really being a bonobo today. Alright, so I have 3 to the 4th when I multiply, times 2 to the 5th, and then x to the what? And y to the 5th. And then from yesterday, I split those up so they're divisible by what?
4.
So 3 to the 4th is fine. 2 to the 5th, I'll split up to 2 to the 4th times 2. X to the 8th is fine, and I split up the y to the 5th to y to the 4th y. Any questions on how I got that? So what's the 4th root of 3 to the 4th? See, I can do all the ones that I'm underlining. The rest have to stay on the inside. So on the inside, I still have a 2 and a y. On the outside, what's the 4th root of 3 to the 4th?
3 squared. No.
Careful. 3. 4 divided 4 is 1. And what's the 4th root of 2 to the 4th? 2. Are we not confident? What's the 4th root of x to the 8th? I heard someone say it. X squared. And then what's the 4th root of y to the 4th? Just y. Now I simplify that. 6x squared y, 4th root, 2y. Boom. I did it the same way as the previous problem, just I happened to prime factorize before I went ahead and did everything. But sometimes we have numbers in front, and then...
Well, I was going to ask is, so this will be in the second quadrant because x is negative and y is 4. I mean y is positive. So since it's in the second quadrant, would you subtract 90 from it?
Hold on. X is,
Negative.
y is.
Positive. So it's in the
Okay,
second
so we're in
quadrant.
the second quadrant. So if you want that measure, add it to 180.
Add it to 180. But I thought you.
I mean, well, it would be 180 plus that, but that's a negative.
I thought you. There's an example.
Give me, draw me a picture, and I'll
Just
explain.
like there's an example in the notes where it's in the third quadrant. You ended at 180. Do you always add it to 180?
No. Draw me a picture, and I'll explain. All right, next one. Next example. I'm going to do it similarly to the one I did before. Now, look up, inspect this with me. Could I do the cube root of y cubed first? Yes. And could I split up this y and do the cube root and then simplify it further? Yes. But I find for most cases, that's a lot of extra work for no reason. The only extra work that's actually worth it will be to prime factorize that 50. So I'll go ahead and do that. So I have 3 cube root 5y cubed times 2 cube root 2 times 5 squared y to the 4th. Okay? Now, I multiply. Well, how do I multiply this? Well, does it make sense to you to just go ahead and multiply the 3 and 2? 6. Then cube root 2 times 5 to the what? Nope. I have a 5 right here, 5 to the 1. 5 to the 1 times 5 squared is 5 cubed. So we're treating our numbers like we would our variables. Times y to the 7. See what I did there? I'm going to take that as a yes. All right, now I need to split up that y to what? Yep, that way it's divisible by 3, the exponent. So now I can do 6. I can do the cube root of the things I underlined. So what's the cube root of 5 to the third? And what's the cube root of y to the 6th? Which leaves what on the inside? 2y. So I get 30 y squared came, cube root 2y. One more, or are you good? One more? One more. And then we need to do division. And division is really going to be the bear. It's going to be horrible. Alright, so we're going to multiply these. I didn't bother prime factorizing that, but I could. 2 cubed, right? Times 3. That 8 is 2 cubed. And then x to the what?
6.
I need to split these up so they're divisible by what? So I'm going to split up that 2 cubed to 2 squared times 2. F times 3. And the x to the 6th is fine. So the square root of 2 squared is 2. I can do that one. I can do the x to the 6th. That's going to be x cubed. And then that leaves 6 on the inside. 2 times 3 is 6. So that's our final answer. I'll give you a moment to copy that down. Okay, so use the principal root, or reference angle. The angle is 63. Now you're finding the actual angle, so I want this angle. So I'm going to do 180 minus 63. Because I want that angle.
What if it's in the third and fourth quadrant?
Well, if it were down here, I'm going to take 180 and add that.
And add it.
Well, it needs to, because it, just use some, use your head and think, if it's in third quadrant, it's an angle bigger than 180, right?
Mm-hmm.
So it'd be 180 plus some.
Okay.
If I'm in the fourth quadrant, then it's going to be way over here. Like, let's say that I get a 20 right here. Positive or negative, it doesn't matter, whatever. I want this. So wouldn't it make sense 360 minus that?
Yeah.
Okay? Draw a picture to help yourself. Alright. Division, 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 division. Alright, so we're going to divide these now. The same rule applies. So here's our rule. We need our index, so if I have the nth root of A over the nth root of B, this rule does not come out as nice as the other one. But here is the basic concept. Basically. We'll put basically. Basically, our answer is going to be the nth root of AB over B. Basically. And it really is just going to take some examples for you to see why this is the case. It basically comes down that we need to rationalize. It means, and we've done that before, haven't we? We can't leave a radical in the denominator. Okay, so here's our starting situation. And some of the questions actually that are in your book are actually easier than the one that I'm going to do. So if they're easier, make them easier. Do it the easy way. Let's say I have cube root of 48 x to the 4th all over the cube root of 3x y squared. This is a big nasty thing. So let me point out a few things. There's going to be a lot of principles that I'm going to talk about that deal with this problem. First thing, you notice how the indices are the same? Okay, that means anything I can divide, I can go ahead and divide. So I go ahead and divide. Go ahead and do any easy division. Don't worry about anything that's too complicated right now. I can go ahead and divide 48 by 3, or reduce the fraction if it's a fraction. So 48 divided 3 is 16, I believe. And you see these x's? Don't I have a rule of exponents with the x's? What can I do there? I subtract their exponents. I get a cube root here, right? But I have nothing that I can do with that y squared. So that's still there. Do you see what I did? Now if I prime factorize that 16, I will see that I can simplify that further. I'm not going to worry about that yet. I'm going to just take care of everything else. So I went ahead and did any easy division. Now here's where we die. I want you to follow along with my reasoning. I can't have a radical down here. So if I need to make this so that this goes away. Well, it would go away if it were cube root of y cubed, wouldn't it? Okay, so that's what I need to make it. So I'm going to multiply it so that it becomes that. So I'm going to multiply by cube root of y. Well, why am I going to multiply by cube root of y? What's y squared times y? Y cubed. You with me? Now, I want to relate that to something that we've already done that's somewhat easier. What if I had 5 over root 7? How did we rationalize that before? We multiplied by root 7, right? It's the same concept as down here, just this one's easier. Why is this one easier? This goes away if it was square root of 7 squared, right? So that's why we did that, and we get 5 root 7 over root 7 squared, which is 5 root 7 over 7. So if it's a square root, it's fairly simple. I just multiply by whatever that is, and sometimes we add something else. We might have 5 root 2 over 3 root 6, right? And then what would we have done? We would have multiplied by root 6 over root 6 and gotten 5 root 12 over 3 times 6, because that goes away. And then I have 5 root 12 over 18, but now we can simplify that root 12. Alright, I'm not going to bother with that right now. I want to finish this problem that we have down here. So we're going to take that, and I'm going to try to move this all up. Maybe you'll cooperate with me today. Please cooperate. You are not cooperating with me. Okay, so I guess I can't do that. Alright, so I'm going to multiply this top, and I get cube root of 16x cubed y. And then at the bottom, I have the cube root of y cubed. So what do I get in the end? Well, I'm going to take that 16 and prime factorize it. And I get 2 to the 4th. So I'm going to have to move all this up here. So I apologize for the disorderliness. So I get 2 to the 4th, x cubed y. And the cube root of y cubed, the cube root of this, is just y. So what I wanted to happen, happened. Now I can split up that 2 to the 4th to 2 cubed times 2. X cubed's fine. Y I'm not going to be able to do anything about. And the cube root of 2 cubed is 2. The cube root of x cubed is x. And that leaves cube root of 2y over y. And that's our answer for that. Yes, I know. Holy smokes. That's a lot of thinking. And a lot of little steps. And my only thing that I can tell you, rather than get overwhelmed on this, is one baby step at a time. until you get used to all the different little things that you can do. Just do one little thing you know to do at a time. So what are those little things? I know that I can divide here, so I go ahead and do that. I know that I can do my quotient rule of exponents, so I go ahead and do that. I know that I can't have a radical in the denominator, so I rationalize. When I rationalize, I just need to get that to be something that I can take the cube root of. So the next one we're going to do is way harder than the one that we just did. Like, how could it get any harder, Mr. King? I'm sick of this already. We'll do another cube root just because, why not? I don't know if this is way harder. It's actually not that bad, now that I see what I wrote up here. Alright, see these? What can you do? What's the baby step I'm thinking of? Reducing, right? And what can I do with these? What's the baby step I'm thinking of right here?
Subtract.
Yep, subtract our exponents. I get a to the third, right? Now, I hope you've noticed, as far as when you're doing your quotient rule, that in the end, it always ends up, the answer always, in the very end, ends up, well, not necessarily always in the bottom, it ends up wherever there's the higher exponent. Okay, in the end, that's the case. So we'll have a b at the bottom. Do you see why there's a b at the bottom? Okay, baby step next. I need to rationalize this cube root. So that means I need a what exponent on this b? Currently it's a 1. What do I need it to be?
3.
A 3. So I'm going to multiply by b squared in the cube root. Because b to the 1 times b squared is b cubed. So I'm going to have cube root of a cubed b squared all over. And I want to write those indices smaller because it might bleed into the next part.
Wouldn't the b be negative because it's 1 minus 2?
Yes. And okay, so let me explain this. All right. So let's say I have that. Here's one way to think of it. Cancel, cancel. Right? Now, if I use my quotient rule,
So if you left like the b on the top, it would be like b to -1, but then you would bring it down. You could just bring it down.
I think you're saying what I'm about to say. So if I just use straight up quotient rule, I get this
Right.
-3, right? When I do it like that, it always ends up in the numerator, and then at the end I need to bring it down. And then I end up with that. But the common sense check is going to be, the answer is going to end up wherever there's the most b's, or the highest exponent. Unless of course you have a bunch of negatives in here, in which case you need to just use straight up quotient rule and then resolve it at the end. So this cube root, now look right here, look right here, look. It is very tempting, especially if you started work and then put it down and then are coming back to it, to be, oh, I can cancel this. No, why did you do this? So that you could rationalize, right? So you would end up going in circles. Okay, we need to go ahead and resolve that. The cube root of b cubed is phi. And then, what's the cube root of a cubed? A. Then I have my b squared here. So this is our final answer. Alright. I wanted to do a really tricky one. And they don't have an example for me, so I'm going to have to make up one.
What?
Sorry. Don't have a conniption. Whatever I want it to mean at the time that I say, oh, they do have a thing. They do have one for me. Yay.
No.
No.
Okay.
Okay. Here is our big kahuna for today. And then we're going to do a bunch on our whiteboards, hopefully. Here's our big kahuna. Alright, so first thing, we need to remember, just like if we had just regular thingamajigs, numbers, we just split this big cube root into top and bottom. That would be our first thing. And you know what? I'm gonna go ahead and prime factorize that 12. And when I prime factorize that 12, I get 2 squared times 3. Now notice in this example, which is why it's the big kahuna, nothing at all divides. And I'm left with a huge mess. I want you to watch the thinking and then write it. So I am going to have to rationalize, right? Nothing simplified. Now I need the exponent on this 2 to be a what? A 3. It's a 2 right now, so I multiply by 2 to the 1. Any questions? Any questions why 2 to the 1? This needs to be a what exponent? A 3. So I multiply by 2 to the 1 when I rationalize. Okay, the exponent on this 3 is currently a 1. I need it to be a something divisible by 3, right? Okay, so I'm going to multiply by 3 squared. That'll give me my 3. You with me? One baby step at a time. I'm doing these one at a time. All of these exponents, I need them to be divisible by the index, which is a 3. So we will have to have one more example after this, because I've got to show you, well, what if it's a bigger number than the index is? The y, same thing, except I multiply by y to the 1. And the z is currently a 1, so z what? Squared. Alright, go ahead and write that, and then I will have the multiplication done down here in a second. I'm assuming that we can multiply. So I'll just go ahead and do it so that you can copy what's up there. Alright, so go ahead and copy these 2 things that I have in blue right here. I'll do the last step in green. And the last step isn't going to be too bad. This rationalizing part is the big, hard part, thinking through that. So I just multiplied my top. There wasn't anything that I could really simplify at all. And again, you aren't going to want to put this down and then come back to it, because then you might be tempted to just start canceling these, and then again, you're going to be going around in circles. Keep in mind, we're trying to rationalize. So now, I look at my denominator. And, oh gosh, this is so nice now. Cube root of all of these. 2 times 3 times y times z. Do you see how I got that? Very nice, beautiful. And at the top, well, nothing is going to simplify at all. So I get this, that's a 9 right there, that 3 squared. So I have 2 times 9 times 5. In the end, that's going to be 90. And I don't have to prime factorize that, because it's already prime factorized up here, and nothing simplifies. So I don't need to go around in circles. And then nothing else simplifies. Now, don't cancel all this, because this bottom is not in a radical. So I can't cancel it. So in the end, I'm going to get cube root of 90 x squared y z squared all over 6yz. There it is. That was horrible. I don't know. I think the polynomial stuff we did last chapter was harder. This is tricky, however. got last year's class and the class before it, so, you know, whatever. You know, it's not bad. Maybe you guys will be the lucky stars that understand it and don't self-destruct. All right, so let's say I'll use a higher root. I'm going to make these shorter examples. So I need this exponent to be divisible by what? 5. So do you see that I multiply by fifth root of what? Well, x to the 1, right? So I have 3 fifth root x over fifth root x to the 10. And what's the fifth root of x to the 10? Huh?
X squared.
X squared. Done. Okay? And one more. And then we are done with our notes and we can celebrate. Okay? I need this one to be divisible by 4. So what am I going to multiply by? Fourth root of what? Yeah. So at the top, I get 6 fourth root x squared all over fourth root x to the 16. Boom. And we got them. And our square face is happy.
Is that homework really due tomorrow?
The homework on the board says it is due on Wednesday, yes. Maybe I'll be nice to you. We'll see. All right. Let's stop.